Okay, we're going to run a fault, and this fault's going to be an overcharged system. We have the system off right now, and if you take a temperature reading, you'll see your temperature is balanced with the indoor temperature of the house at 90 degrees. If this system had incondensables in it, you would not balance your temperature at the same temperature as the house temperature. If you pull this refrigerant out into a recovery tank and check the temperature on that tank, it should be pretty close to the temperature outside. If it is not, you've got incondensables in your system. When you do recover some refrigerant, it's a good idea to put a few filter dryers on there. You might get lucky and get some of that moisture out as you're pulling it out. That's if you think it's got incondensables and not pure refrigerant. This happens a lot. A leak can cause incondensables or air to get into your system. Also, just sloppy hooking up gauges with air in the line. People get in a hurry, so you can start picking up incondensables, which that air breaks down into moisture, which breaks down the refrigerant into acids, causes all kinds of problems, and then the system doesn't run correctly. But in this case, we have an overcharge. When you turn it on, you instantly see the pressures going up. And the temperatures, the corresponding temperatures are just too high. They're high on both sides of the system. You're high on the evaporator at 55. You're high on the condenser at 145. Again, I believe if you had incondensables in your system, this temperature might be a little warmer because your subcooling would be a little less. But here your subcooling is 20. I'm not sure on that one. We'd have to try it. We've got a superheat of about 12 degrees. And the big problem here is that suction line is just way too warm at 67 degrees. That's a warm suction line. That's high pressure. You're overcharged, so things just are not looking right. Let's see what we're getting off of the evaporator. Let's see what the supply air is. Supply air is 85 degrees. No wonder it's 90 degrees in the house. It's just not going to cool down. Let's see what the compressor discharge is, and I'm going to guess it's 140 degrees. Whoops, not compressor discharge. Well, let's look at it. And the liquid line, what was the liquid line again? Liquid line was 125. So let's see. What is the condenser outlet doing? Right on the outside of your condenser where the fan is, we do have 140 degrees. So basically what we see in the simulator is the temperature blowing out of your condenser is usually 5 degrees less than what it is changing state at. Once again, you have a liquid line at 125, so your change of state is 20 degrees subcooling. Curious, do we have any issue with the cap tube? No differential. Do we have any on the filter dryer? No differential. Any other temperatures we want to check? And I'm just looking at mechanical again. We're not getting into the electrical side yet. So there's 131. So that is our fault. Simply overcharged with refrigerant. Let's see what happens if we drop the temperature. No, not the indoor. Let's make the outdoor temperature. Let's make it a nice 80 degrees, 40% humidity, not humility. And I'm running a 60 to 1. ratio so the time's moving a little quicker so it balances faster. What happened to our temperature? Well, our head pressure dropped, and now it's a temperature of 130. That's the change of state, so that should be blowing about 125. Evaporator's still pretty high at 51, and it's blowing out 81 degrees on the evaporator, and the suction line is and I don't think the indoor temperature should be 90. Let's speed things along. As we dropped the indoor temperature, we did drop the evaporator pressure. It dropped it down to change in state at 47. Dropped our suction line to 54. Still pretty warm though. What we basically did was we took the excess heat load out of the house because I originally had it at 90. Had we left it running, it would have eventually dropped down to this anyway. We do have the supply is at 67. So it's blown a little bit of cool, not much. The return is 67. So, and that makes sense. The return should match whatever the indoor temperature is. And our delta T is 67 to 80, which is 13. Not a very strong delta T either. So those are some of the pressures and temperatures. We're to bump it up to 102. Miserable day. That indoor temperature should start climbing. I would think that would get to 90 degrees pretty soon. Again, you've got a very warm evaporator, very high head pressure. And typically we are blowing out here 5 degrees cooler than the change of state. I like to check that on a unit and just see how close that is to true. Later, we're running 5 degrees cooler than what the change of state is. This is probably an 8 to 12 SEER unit. It's not going to be your super crazy high efficiency units that they're coming out with now. That would probably change that standard right there. Okay, so we have thoroughly looked at the conditions on this little system, 3-ton system with an overcharge. We're going to do the repair, and the repair is going to be first mark that it's inadequate cooling and its refrigerant overcharge. The solution is to recover refrigerant and to recharge it. We're going to weigh in a charge. Indicated by high pressure and high suction pressures and high compressor current. Oh, we didn't check that because we're not there yet. If in doubt, remove the charge, weigh in the proper charge. So, things to look for with an overcharge: high head pressure, high suction pressure, and high compressor current. It'll be working very hard. So we're going to do our repair, and I'll retest it. So start it up, and we should start seeing some positive things real quick. I like to see what's coming out of the supply air. Watch that drop, and it is dropping. Even though it's 102 degrees outside, we are steadily dropping our temperature on the inside. We are all good. That's dropping pretty fast too. It's going to finally stabilize at around 20 degrees delta T once the heat load is sufficiently brought down. The indoor temperature is still dropping. And all is well. That concludes our fault simulation of an overcharged system. Thank you for watching. We'll pick up the next one.